Hey everyone, thank you for taking some interest in this little video. I am Alex DeRosa. I'm a professor in mechanical engineering here at Stevens. Like many of you, I read a book, What the Eyes Don't See by Mona Hanna-Attisha, and I thought it might be interesting to talk a little bit about the history of lead in gasoline. The reason I thought that was interesting is because not only do I teach some of the automotive engineering courses here on campus, but I also advise the Society of Automotive Engineers. Every year we design, build, and then go race this off-road vehicle at various different places around the US. It's a really cool, fun project. If you're interested, reach out to me, or I'll give you the link to some of the students later on in this presentation. So before we talk about lead in gasoline, let's see how a typical internal combustion engine works. And you can see an animation here on the left. This is the 4-stroke cycle. And so what happens? Well, we suck in air and fuel, we compress it, we burn it, that's where we produce power, and then we exhaust the leftovers. Right? So if you watch that again, here we've got combustion, then exhaust. So we intake fresh air and fuel, we compress it, we burn it, and then we push whatever's left out of the exhaust. And you can show that the efficiency of this type of engine is actually proportional to what's called the compression ratio, the ratio of the maximum and minimum volumes inside the cylinder over the course of a cycle. So you might think then, well, if the efficiency is related to these volumes, why not make the maximum as big as possible and the minimum as small as possible? Well, the maximum volume is obviously limited by the size of the engine, right? But the minimum volume is actually limited by something called auto-ignition or knocking. What do we mean by knocking or auto-ignition? On the left here is what might be termed a normal combustion process. We compress the fuel and the air and then burn it using a spark to ignite the mixture. And so we have a spherically expanding flame that's fairly predictable. It starts off near the spark and then expands through the chamber. If instead we look at the image on the right, this is premature combustion, auto-ignition, or knocking as we've come to call it. What happens here is we've compressed the fuel and air so much that its temperature has gone up and it has gone above the ignition temperature. So it auto-ignites, it spontaneously starts to burn because we've compressed it too hard. This is a problem because now the process is more random, it's not controlled, we don't know exactly what's going to happen, and it can damage the engine and cause losses in power and efficiency. Obviously we want to try and prevent this auto-ignition, but we would like these higher compression ratios, these smaller minimum volumes, to increase the efficiency. So in order to tackle this problem, we try and prevent this knocking or auto-ignition by adding different things into the fuel. We can add things like ethanol. That's actually what we do today. It's a good solution. Ethanol is non-toxic, it's easy to come by, it's an agricultural byproduct here in the US. We could also add iodine. That's not a particularly good solution because iodine is corrosive. There are various other heavy metals and things we can add to engines and fuel to prevent auto-ignition, but what we're going to talk about more in this discussion is tetraethyl lead, often abbreviated as TEL. This is a substance that was discovered in Germany in 1854, but remained unused at the time because the scientists knew it was toxic. Right? And you can see a molecule of TEL here on the right. It's a lead atom in the middle, surrounded by some carbons in black and hydrogens in white. And so, as I said, we've known lead is toxic for a long, long time. Unfortunately, GM, DuPont, and Exxon, then known as Standard Oil of New Jersey, promoted the use of TEL as a fuel additive in the 1920s. Why was this if lead was known as toxic? Well, TEL was patentable for its use as an additive in fuels. But GM, DuPont, Exxon, they knew that lead had some health connotations, right? People were scared about its use, knew that it was toxic, and so they often tried to avoid calling it tetraethyl lead. They called it ethyl or TEL to avoid some of these links and health concerns. And as we can see, right, like so many things, it's commercial interests that are driving this decision. These companies used TEL rather than something like ethanol, which they knew of at the time, because they could make money from using tetraethyl lead. They couldn't make money by putting ethanol into the fuel. What's good, though, is that almost immediately various folks in the health field, other scientists started saying, hey, this is a bad idea. Alice Hamilton, one of the folks that the author of our book commented on, right? she said at the time that this was a bad idea. Right, during all sort of the 1910s and 1920s, Alice Hamilton was saying that lead exposure was bad. And this led to the US government in the 1920s to actually do some research into the use of lead as a fuel additive. Unfortunately, their results were inconclusive. And after this, these companies that were promoting and using TEL funded most of the research that was done. And so there's a real conflict of interest in a lot of the early research into the health impacts of lead in fuels. So through the 20th century, there was actually a lot of discussion about the health impacts of lead. There were some court cases and so on. But unfortunately, these companies that were producing tetraethyl lead managed to find ways to circumvent all of these problems. Much like we saw in our summer reading, the folks involved wanted to continue to make money, right? And they found ways to continue to do so by appealing, taking people to court, sort of tearing down these advocates for public health. And it was really only in the 1970s that we began to seriously reduce lead levels in various different areas, including in use in gasoline. The US EPA, the Environmental Protection Agency, amended the Clean Air Act. They were motivated by health concerns, as well as the fact that lead negatively impacts catalytic converters. These converters help reduce pollutants emitted by the engines, and lead was stopping them functioning properly. And then in 1986, they actually outlawed the use of lead in automotive gasoline after they tried various other methods, right, like capping and trading. Other limits hadn't worked out like they had quite planned, so they banned it outright in 1986. You can see on the left of the slide here just a plot showing the lead in children's blood, right? So these are blood test lead levels. And you can see on the left, 1970s, there's high levels of lead in children's blood. But after we've introduced some of these regulations, like the Clean Air Act, like the Lead Contamination Control Act, we really were successful in reducing lead levels in blood. Unfortunately, though, actually you can still get leaded fuel in the US and in many other countries. Aviation fuel for airplanes in the USA can still contain tetraethyl lead at amounts that was twice what was ever allowed in automotive gasoline. Innospec, which is an American company, continues to sell tetraethyl lead to other countries like Iraq, Yemen, and Algeria. You can see those countries in the map of the world on the right here. They're the ones that are shaded in lighter orange. They still use leaded fuels. This company, Innospec, was actually found in 2010 to be bribing officials in some of those countries to allow them to continue to use TEL in their fuels. Some racing competitions, NASCAR for example, still use lead additives in the early 2000s as well to help prevent auto ignition. And so the final image I'd like to finish with here is this image of the pumps, right, in the top right. You see this unleaded moniker whenever you go to get fuel. Now perhaps you understand a little bit more about what it means. It means that there are no lead additives put in those fuels. You might also see that the fuel contains up to 10% ethanol, something like that. That's the additive we are now using to control auto ignition here in the United States. So this is a list of references where I got some of the information for this presentation. You might be interested in taking a look at some of these, particularly The Secret History of Lead was a really interesting read for me. I've also got a link at the top here to the Stevens Society of Automotive Engineers for any of you who are interested in helping us designing and building this race car. I look forward to seeing you folks sometime soon in our garage. Best of luck with the start of the year, everybody, and thank you for watching this presentation.